Victoria LaFont is also one of the lead instructors for Nutritional Therapy Association, is an athlete herself, lives at high altitude, and the topic for Victoria's presentation today is Cross the Line Like a Rockstar. It's definitely as juicy as Kathy's presentation in terms of the references and resources. I think Victoria is a self-proclaimed research nerd and athlete. So if you want the good resources, you're in the right place. I'll give it to Victoria.
Thanks. Hi, everyone. Okay, so I just want to say, first of all, I'm so proud of NTA for maintaining our bio-individual base. I think that's really important in today's blogosphere. So today I'm going to be talking about how we adapt. So I didn't realize this, that when we start to work out, there's some physical adaptations that happen that help our performance. And then I'm going to give you something to do with that information, so I'm not going to just fill you up with kind of nice facts, and then you go home and you're like, well, what do I do now? So Matt mentioned that I was an athlete. I would say kind of an athlete. This is me as a youth, so my beginnings in t-ball. And then I played basketball and soccer and did yoga for many years, and then this is just an obligatory 80s Kentucky kid picture. I asked my mom to send me the most awkward picture available, and she delivered. She totally came through. So in 2014, I got certified as a Polestar Pilates teacher. That does not mean I spin around on a pole. That is what most people think. Polestar Pilates is a really PT-based, A&P-based Pilates school. And that took care of a lot of alignment issues I was having. I loved moving in that way, so I got a little bit more involved with them. And then in 2015, I met the love of my life, who I describe as an exercise maniac. And then he got me into what I call my 14.5, because he was training for his 70.3 half Ironman. So that's us at my little sprint triathlon. So I'm getting more and more interested in movement as I get older. And then last but not least, had a pretty stellar staff of teachers at University of Western States in a sports nutrition class. There's some purity when all you're really interested in is winning, and that's what they were interested in. So when they're reading the research, that's their bottom line. And bias kind of gets pushed to the side when you just want to win. So what happens when we get in shape? We all know that something occurs. We maybe feel better, we look better, we have more energy, and that is adaptation. So how do our bodies adapt? We're going to cover that today. And then most importantly, like I said, how do you take that home with you? I really love all kinds of research. I'm kind of a research head in that way. But I sometimes get frustrated when I go to talks and I get all this information, and then I'm like, well, what happens now? Like, what happens when you go home? So adaptation is truly amazing in our bodies. The 4 types of adaptation we're going to cover are phenotypic adaptation. So we all have a specific phenotype. That's our genetic expression in the world. Our genotype is set. We can't change our actual DNA, but we can change the way it expresses, and exercise does that. We're going to talk about glucose metabolism and glycogen storage and utilization. Kathy did a bang-up job going into that a little bit in her talk. Mitochondrial adaptation, which is like, I might go a little crazy up here. It's so exciting to me. That's a really cool part of adaptation. And then last but not least, the beneficial aspect of reactive oxygen species. So genetic adaptations. Our gene expression actually changes when we begin to move. So it's a pretty incredible thing that happens. Muscle cells detect the mechanical movement, and then through our nervous system and our endocrine system, there are signals that translate into changes in the muscle genome. Just let that in for a second. So we know that diet affects genome expression. We know that lifestyle affects genome expression, but so does movement. So this really particular form of lifestyle, which is pretty incredible. So when you train regularly, your body genetically adapts to that training, and then we have greater resistance to fatigue. So any athlete will tell you that that's a huge issue. If you're mid-race and you start to get tired, sometimes it can be game over if you bonk out. So having that genetic support, pretty incredible. Training-induced phenotypic adaptation is the consequence of repetition of the stimulus of individual exercise bouts. That's the nerd world I live in every day. In English, all this means is you train, you genetically are changed, you perform more optimally. So the good news is for most of us, how many people work mainly with athletes? Okay, so a few, which is super cool, so you can bring home some specifics. My main group of clients, they're just looking for long-term health, help with chronic illnesses. So I'll focus a little bit on that today also, so you can take that home. The beneficial adaptations for movement are not just limited to the muscle cells. They're also in the brain. Pretty amazing if you have people with neurological issues. Adipocytes, that's our fat. Buccal cells, that's in the cheek. I think that just happened to be a research point that showed up, so we get it. And then some peripheral blood cells like leukocytes. So those changes in the genetic expression counteract aging and disease. So that's not just good for performance at that point. We're actually counteracting aging. And those adaptations are probably passed on to kids. So the Ironman athlete over here, maybe that's his goal, to pass it on to his kids. And going through these slides initially, my partner was like, maybe you should have like a pregnant woman exercising. And I was like, yeah, it's a good point, but we often forget that the mom and dad genes both get passed down to the offspring. So good to remember. So the caveat to all of this, which if you're an athlete, this is a really hard one to let in, is balance. Balance is key for these adaptations and definitely for long-term health. When I was in my sports nutrition class at UWS, my professor said, this is not health and wellness, this is performance, this is athletics. So I get that mindset can be prevalent in the community when we want to cross the finish line first, but as a practitioner, I'm thinking like, I want you to get to 90 years old and still have full function. Heavy, prolonged exertion is associated with numerous hormonal and biochemical changes, many of which change our immune system. So you all, that is really important. We can press so hard that we actually affect immune function. So next up on the chopping block is glucose and glycogen. So some pretty interesting facts up here. I'm gonna quickly go through them, but like Matt said, you're gonna have the slides to reference later. Skeletal muscle is actually the predominant place that glucose is stored in the body under insulin-stimulated conditions. So as practitioners, I think we often consider the liver as the main place that glucose is stored, but it's actually the skeletal muscles. And they have a 4-fold capacity of the liver to store glucose, which is pretty incredible. So as far as fueling, I love that Kathy went into this already. Glycogen stores continue to be the main place that fuel is pulled from for performance, especially at a higher VO2 max. So we're talking 70, 75% VO2 max, which starts to get into like really top level athletes. So a nice review from Close, Hamilton, Philp, and Burke Morton. They claim that carbohydrate remains king. So one thing that I really work through in my practice or in speaking is myth busting, which I have sometimes referred to as blog busting. Humans work in trend. It's part of what we do. We have trends in fashion. We have trends in food also. We have trends in medicine. A ketogenic diet is very trendy right now, but I love that Kathy pointed out it may work for you and it may not. So it's worth experimenting with your unique body. Always consider bioindividuality. And then what are you doing? What is the work that you're fueling for? So this is really interesting and I think is something to consider. An athlete exercising in a carb-depleted state experiences larger increases in circulating stress hormones and a greater perturbation of several immune function indices, again in English. That means that a carb-depleted state for some people can actually create an imbalance in the immune system. Okay, so everyone's carbohydrate macronutrient ratio in their diet is going to be different. That's part of our bioindividuality, but it needs to be substantial, especially if there's any underlying immune imbalance already. Deficiencies of protein and certain micronutrients have also been associated with immune dysfunction. So that's something to consider. Really interesting insulin fact, a single bout of acute exercise will improve whole body insulin sensitivity for up to 48 hours. So what does that mean for your clients who have blood sugar dysregulation, whether it's pathogenic or not? It's really, really interesting. Endurance training leads to more expression of a glucose transporter that actually pulls glucose into the muscle cell. So when you exercise, you have more expression of those to the kind of edge of the cell where they can pull the glucose in, and you have greater genetic transcription of those transporters. So again, we're seeing the genetics play in here. Another interesting part of exercise, there's insulin-independent pathways that are also more highly expressed with movement, and these are dependent on muscular contraction as opposed to insulin. Okay, so all athletes want to stay out of here during the race. That's a big one. It's really important. So the way that you do that is you mix your sources of carbohydrate. How many women are here? Hi, Nutritional Therapy Association. So I spoke to this a little bit more because I know we are primarily women at the NTA. If you haven't heard of Dr. Stacy Sims, I highly, highly recommend you looking her up, especially the people who are working mainly with athletes or if you're a female athlete yourself. So her recommendation is mixed multiple carbohydrates as glucose and sucrose at about a 4% concentration. If you get a little bit more than 4%, you're kind of walking the line up to 8%, which is kind of the traditional Gatorade sport drinks. You may end up here. Maple syrup is her preferred form of mixed carbohydrates because of the nice ratio of glucose to sucrose. Women cannot absorb as much fructose in the GI tract. That's something really important to remember. So if you have female athletes that continually have GI disturbances, look at their form of carbohydrate during a race. They may be getting too much fructose, honey, fruit, in the whole food realm. The other really interesting part of mixed multiple forms of carbohydrates, it improves dehydration. So it helps us stay hydrated as we perform. That is a really big one for athletes during long races, you all. So this is a really cool one for nutritional therapists. We're starting to see in the research evidence of the validity of lingual neurotesting. So the LNT process is now kind of indirectly showing up in research through what is called carbohydrate mouth rinsing. So this is a non-metabolic effect of carbohydrate. They believe it works on the central nervous system. So rinsing carbohydrate in the mouth for 10-second periods every 5 to 10 minutes during exercise may be helpful to performance, ergogenic. It improves performance. You guys, that's our stuff in the literature. That is amazing. That's so cool. We haven't seen that before, so we're seeing it now. So that brings a little bit more validity to the Western mind, which loves research and facts, to what we're doing every day in the office with clients. We know it works because we have the clinical experience, but we're seeing it here now with athletes. All right, so exercise does equal mitochondria. That's a pretty buff little resistant trained mitochondria there. So Kathy gave some amazing facts about mitochondria. I didn't realize how much of our body weight they make up. I just knew there were a lot happening. So it's good to remember our macronutrients, their purpose in the body is to get turned into ATP. We're like little batteries, and that's our energy source. And mitochondria is the way that happens. So cool things about movement. Regular endurance training has been shown to increase mitochondrial content, so you get more when you move, and the ones that you have get bigger. So what does that mean? You have more ATP. That is mind-blowing. When I read that the first time, I just sat the book down and walked outside. I was like, what? Science is the coolest. So 5 months of endurance training equals systemic mitochondrial biogenesis. Biogenesis just means more, new creation. Prevention of mitochondrial DNA depletion and mutation. Mitochondria have their own DNA separate from our human DNA. So movement helps the depletion and mutation of those, and then increase mitochondrial oxidative capacity, which means they can make more ATP for you, equaling less fatigue, so fatigue resistance. You guys, I can't tell you how cool that is. Are you amazed? Yeah, it's amazing. Okay, so even more amazing in our world with our focus on digestive health as one of our main foundations is the link between mitochondria and the microbiota. So I really urge you to read this review. I actually emailed one of the women who wrote this review, and she wrote me back. They're really open to hearing what you have to say about this paper and how much you love it. So check that out in the references when you get them in the PDF of the slides. There is a crosstalk, so there's a connection between our gut microbiota and mitochondrial formation, the biogenesis. This occurs mainly through the endocrine and the immune systems, so important to keep those systems balanced and healthy. And mainly we see this happening through the creation of short-chain fatty acids and then the secondary metabolism of our bile acids. So going back to proper diet and liver gallbladder function. Gut commensal microbiota also reduce reactive oxygen species through the short-chain fatty acids such as butyrate. One of my favorite products is the CalMag butyrate product that Biotics has for help with gut function. And many of you have probably seen that LNT well in your office. So a little bit about reactive oxygen species. They are a normal part of respiration. Mitochondria produce reactive oxygen and reactive nitrogen species, and they have really important roles in cell signaling and balance, homeostasis. So they're not always just to be squelched out with antioxidants. Only excessive amounts. So that's what we're on the lookout for. Is there too much, so much that there causes inflammation? Balance is key. That is so important in all endeavors, but especially with athletics and athletes' long-term health. So I don't know how many of you have seen The Princess Bride. This is how I think of reactive oxygen species in the body. Not to be confused, however, some reactive oxygen species do serve an important purpose in performance adaptation. So ROSs, reactive oxygen species, are basically just unstable molecules that are searching for a way to become stable in the body. And they can create, they can create damage looking for that stability. So get out your medical dictionary here. Exercise-induced ROS production equals vasoregulation, so blood flow regulation, fibroblast proliferation. Basically, these are the cells that create collagen in the body. So if you're working with someone with a connective tissue disorder, movement is really important, and so is a balance of reactive oxygen species, okay? Muscle hypertrophy, like that little mitochondria, you get bigger. Increased mitochondrial biogenesis, you get more. Induction of antioxidant enzymes, so the body is self-regulating. Regulation of immune responses to eliminate antigens. And angiogenesis is new blood vessel formation. So these are all awesome things that we want, and they come from this thing that we don't often think of with favor. We kind of usually want to get rid of them. So long-term exercise equals upregulation of the body's own antioxidants, which is pretty cool to see that change. And then this was so interesting to me. So Holland et al. Basically found that when we start to move, we can decrease inflammation and help intestinal permeability. So leaky gut. That's incredible for us as nutritional therapists. So make sure to find that link and check that out in the reference section. Okay, so you have all of this biochemical blah, blah, blah. What do you do now? Like, what do you do when you get home? Eat all the things. So I am a really big proponent of eating a balanced diet. We're omnivorous. That's how we evolved. And really, at the end of the day, what we're after is metabolic flexibility. So that's the big thing that Kathy was kind of pointing towards in her talk, is we need the function to use all macronutrients to make energy. Diabetes is a perfect example of lowered metabolic flexibility, and we don't want to create that in our bodies. So no, really, eat a balanced diet. An adequate balance of carbohydrates, proteins, and fats, that's dependent on what works best for your particular body. And then balance that with your daily caloric intake and total energy expenditure. So there's all kinds of equations online where you can figure out how many calories you really need. Just to put this out there, the World Health Organization says that for females, under 2,000 calories a day is considered starvation. So remember that, especially when you see clients that are doing really long-term low-calorie diets, it's not going to end well, especially if they're wanting to perform. So just to keep in mind, your caloric needs are going to really depend on what you're up to. A sort of athlete like me is going to have way different caloric needs than a competitive athlete. A ballerina versus a female shot putter, you can see the difference. And eat what works best for your body, not what is trending right now in the blogosphere. That's a hard thing to let in when we're so influenced by outside influence. You know best. You live in there. So what about carbs? That's kind of the pink elephant, right? So a high carb diet actually increased athletes' ability to use glycogen stores during exercise. You have somebody who wants to cross the finish line first. That is really important. And this reference is Juke and Droop 2014. So if you're following this and you want to read about this directly, that's the reference to check out in the list. So your body is more easily able to utilize glucose if you have that macronutrient coming in regularly. And like I said, for competitive athletes, the sodium-dependent glucose transporter 1 is one way that this can happen. We can upregulate it with a little bit more carb in our diet. Now, am I talking about carbs like scones and pasta and, all of these more processed ones? No, I'm talking about really whole food forms of carbohydrate that we know. In animal trials, we've also seen that table salt, sodium chloride, and fiber showed positive effects also for glucose transport into the cell. So something to consider. We haven't seen it in human animals yet, but we have seen it in other animal trials. So the reverse situation may also be true. A little bit more carb in the diet can help carb oxidation. Lower carbs in the diet can decrease our body's ability to use carbohydrates as a fuel source. So I think about this long term. If we're on a long-term ketogenic diet, if we're long-term cutting out any one part of the diet, enzymatic downregulation is what occurred with carbohydrates via decreased muscle pyruvate dehydrogenase. This is a really important enzyme to know as it brings the glucose into the Krebs cycle so that eventually it can get turned into ATP. However, low-carb training can be really beneficial for adaptation. So let's take a step back. Low carbohydrate training sessions, or adaptive training is another word for this in the literature. It can maximize mitochondrial adaptations and new blood vessel formation. So while long-term isn't great, every once in a while, low-carb training for a serious, especially endurance athlete, can be really important for adaptation. So here's some tips for that. These sessions should be completed in caloric deficit, so maybe like a before breakfast training. Pre-training drink of caffeine can help the perceived effort. So oftentimes when glycogen stores are low, intake of glucose is low, athletes feel like they are just running through tar. So caffeine can help that a little bit. The exercise should be low intensity, but for a little bit longer time spans. So as Kathy was saying, when we kind of get down into the 60% VO2 max, 55% VO2 max, we do burn more fat as fuel. So this training reflects that. And then it's important for the competitive athlete just to use a few of these adaptive sessions with many more performance-based sessions so that they continue improving. We're just using this to get more mitochondria, basically. All right, so some more carbohydrates in the diet. In order to feed the bacteria that form short-chain fatty acids to help with the mitochondrial biogenesis, first we have to balance the gut. So how many clients do you have where you are not able to give them many carbohydrates or they start to have gut issues? Do people have those clients? I definitely do. So the first step with this is we have to balance the gut and use all of your clinical knowledge to do that. You have those skills. So once the gut is functioning optimally, again, we know this may take some time, then reintroduce poly and oligosaccharides, resistant starch, dietary fiber, all of these really wonderful foods that feed the bacteria that make the short-chain fatty acids, butyrate, acetate, propionate. These are the fatty acids that work with the endocrine and the nervous system to create more mitochondria in the body, something that everyone wants for less fatigue. So some examples of that: plantains, delicious, cooked in a little bit of coconut oil with some sea salt on top. Incredible. Green bananas also are high in resistant starch. Potatoes, burdock, an excellent herb for the liver that I often tell people to put into their bone broth when they're cooking it. Cooked and then cooled rice, oatmeal, and legumes. Legumes also in the literature all over the place, super helpful for blood sugar regulation, especially in the diabetic population. We forget about legumes. It's a really amazing food. All right, so training the gut is important too. As many of us know, if we go out hard and we're maybe eating or drinking a sports drink beforehand and we haven't done that, we are gonna end up on the side of the road and lose a sock. You know what I'm talking about. So you have to train the gut to eat what you need to eat to perform. Yeah, I heard that, you know. So in order to increase capacity to absorb and utilize carbohydrates, we have to use them a little bit. And actually in the study, Jukendrup cites competitive eating. So this is someone that actually my guy introduced me to, Matt Stoney. He is the current world champion with the all-time record of 69 hot dogs with the bun in 10 minutes. So showing that it can be done, it should not be done, but it can be done. So what Jukendrup recommends is training with relatively large volumes of fluid, especially if you're gonna be in heat, training immediately after a meal. If you're in an endurance race, you will probably have to eat at some point, and generally it is recommended to drink your drink and eat your food. I know that sounds a little counterintuitive, but sometimes athletes try to get in everything through fluid, and often in the GI tract that does not work well because of osmotic disposal, okay? Training with a little bit more carbohydrate, we showed it can increase your body's ability to use that glucose and to store more glycogen. Simulate your race conditions. We all know that when we're working with athletes. You have to simulate your nutrition plan before your race, and then kind of back to just increasing all over carbohydrates to improve metabolism. Okay, so as far as antioxidants go for the reactive oxygen species balance, use whole foods. So unless I have an athlete that really shows a need for supplemental antioxidants, let's say they have long-term chronic issues that they need antioxidant support, even in that situation, normally I'll just use whole food form vitamin C. I'm gonna use whole food. So white potatoes, who knew they were high in antioxidants? I didn't, but that is true, they are. We know all the good berries, blueberries being the highest, apples have an incredibly high profile of antioxidants, beans, and then prunes also. Again, maybe not the day before a race. Okay, so one other way that we can optimize adaptation is through altitude, and athletes will often go train at altitude in order to have better performance at lower elevations. So we can see up here increased erythrocyte volume and hemoglobin content, so higher red blood cell concentration, increased mitochondrial volume, so we see that come back again. So the ideal is to live high and train low, but who has time to like live in Tahoe and then go train in Sacramento? I don't. So I went through this with a good friend who is an incredible competitive Ironman, and she said, well, yeah, they have us sleep in training masks. That's so cool, right? So they wear masks that simulate elevation, and then they take them off in the morning and do their performance-based training. So they basically are sleeping at altitude, performing at a lower altitude. Benefits are still seen within 2 to 3 weeks of exposure or simply training at altitude. And that is the highest peak where we live in Tahoe. That's next on our list. So some of you may know Wim Hof. Have you all read about him? The Iceman, he ran almost to the top of Everest in his shorts. Pretty incredible guy to check out. There's a TED Talk with him and a doctor kind of explaining the science while he's getting buried in ice. So there's a debate, though, about the effects of cold water immersion therapy with adaptation. Does it help it or does it hinder it? Because maybe what you're starting to realize is that adaptation comes with a little bit of stress, right? One theory is that it actually reduces performance adaptation because it helps take down some of the stress after performance. So 2 different studies show 2 conflicting views, which is the beauty of science, is that we actually don't know what is going on. So we have to take all viewpoints. So Isan and company found that it actually enhances adaptation. This is specifically for endurance athletes through mitochondrial biogenesis. So yay, more mitochondria, less fatigue, awesome. But with resistance trainers, it was found that it could deplete muscle hypertrophy. So not necessarily strength and bigness in the muscles are kind of 2 different things, but if your goal is to get big, cold water immersion therapy may not be for you. And it's particularly excellent for women immediately after exercise. Women tend to have more vasodilation as compared to men, and we tend to have more orthostatic hypotension, so that the Raglan sign, right, that's the perfect example. Our adrenals it just happens that after exercise, we're more susceptible to that. So for men, it's best to wait an hour and do cold water immersion therapy or even just compression. For women, it's better to do it immediately after exercise. And again, that's Dr. Stacy Sims. You can tell I have a pretty big t-shirt crush on her. She's incredible. If you just go on PubMed and type in Stacy Sims, her studies are gonna pop up, and her book is Roar. Really wonderful researcher for women. So last but not least, heat adaptation. So I just threw this in mainly because I know that we are a lot of women in the group. If you're going to perform in the heat, you have to train in the heat. That's just kind of how it goes. And what you're shooting for is acquired thermal tolerance, ATT. So here's some steps on how to go toward more tolerance to heat. Begin acclimatization 3 weeks prior to competition, and then you work up. Work out in a warm room with cotton sweats. You can read through these. Kind of the main one I want to focus on is generally they say to drink more water than your thirst sensation signals, along with some electrolytes. Again, no more than 4% of your drink. However, there's some caveats for women in our cyclic phases because our hormones affect our water balance in our body. So women training in the heat during the high hormone phase of the cycle, for most of us, that's the luteal phase. If you're on birth control, that can be a little bit changed. We have to consider that. We have additional challenges in the heat because of the female sex hormones and the influences of these hormones on fluid distribution, our core temperature, and the way that our body deals with heat. So this is really important for your female athletes. So the way that you can regulate this is through pre-exercise ingestion of a more concentrated sodium beverage. So ones that we really like, chicken soup, that should be super familiar to everyone, miso, and then just putting some salt in your water. And that's it. Thank you so much.